let's look at data visualization. Let me share my screen and we quickly do that. Okay, wherever you are, greetings. My name is Biba Bright, and I like to do my data analysis with R programming. So today I will be teaching about data visualization, and I'll be using the ggplot2. I'll be doing another session which I'll be using Plotly to be able to do that, and yeah, we see how we can create an image from our data. So, for instance, if you see an image like this, it looks quite beautiful, right? So we have these were initially figures, then we have turned the figures into an image, and then for us to be able to make a clear understanding or to have a clear understanding of what it is. So let's look at what exactly is data visualization. It's actually turning your data into an image, into a graph, into a plot, or into a figure in which you are able to see the actual pattern. And that is it. We are going to be using the ggplot2 package. And I hope so. So I'm not teaching from this part, I'm teaching from... so I will try my best and see if we can generate as many, as many projects as well, or as many as possible. But I want you to get the syntax of ggplot2. So this package called ggplot2 is actually grammar of graphics. And this is the syntax as to how it works. You first of all have a data, you have mapping. The mapping tells you how you want the variables to interact. Let's say, how do you want, which one is going to be on x-axis and which one is going to be on y-axis, and which ones are going to be represented as something else. So that's what we call mapping. We also have geometrics. The geometrics simply tells, that is where we choose the kind of image we want to generate. Then we have our statistics, and then that is why we are able to provide, let me use the same word like the statistics part of it. We have this particular function called facet wrap or facet. The facet allow us to be able to divide the data according to, let's say, a year, maybe, or a gender, or according to a specific given number of variables. And then the data will be analyzed, and then in each particular section, it's like sectionalizing the data. We have coordinates, and then I think we understand this. We have labels, like you can label your x-axis, your y-axis. You have teams. The teams allow you to choose the background of the image, and then that's how it works. Now, this is the basic syntax of ggplot2. So if you have it, you have ggplot2, the first entry is always taking the data, and then followed by the mapping. And then you can add other, other things as you have it there. Now, let's begin with this one called, a BOD. It's actually a data on time and then demand. And so we want to try our possible best to see how we can visualize what kind of data it is. But you see, when you use names and you put any data frame into it, it's simply going to give you what the names of the variables. So we call that the name function. The name is a function in itself. And so if I have, let's say, names like this, if I have names, if I come here and I have another one called CO2, CO2, yeah, CO2, there are quite a number. It's a data frame. So if I put it there, if you run it, it's going to print the variable. It tells you that these are the column headings. So you have plant, you have type, you have treatment, you have concentration, you have uptake. And that's how it is. So you just try to have a glimpse of the data that you want to visualize. Now, there are other ways to check whether the data has some kind of, but I'll come to that, which is called data cleaning. So now, if you have this, then this is the first step. The first step is I'm taking the function called ggplot, you see, The first step is I'm taking a function called ggplot. The package is called ggplot2, but the function itself is called ggplot. So if I have ggplot here, my first entry should be the data. It's going to ask me of where I'm getting the data from. So let's say I'm getting it from the data frame I just mentioned, any of them. So it's a BOD, and then that is it. It's separated by the next thing is comma. The comma is followed by the mapping. That is, how do you want the variables to interact? So I'm going to have my mapping here, and then that one to give me equal sign. So that's going to take me to aesthetics. The aesthetics will allow me to be able to indicate whether uh, I can now indicate y is equal to this, x is equal to this, and that is it. So I can say, uh, what is it, my x axis, uh, or let me say my x is equal to, that's why you always print the column name. So you know which particular column is going to be your x-axis and which one will be your y-axis. So in this case, I'm going to pick time as my x-axis, and then I put comma there, and then my my y is going to be, let's say, demand, and demand is actually spelled in lowercase. And then if I leave it at this point, then you run it. It's okay. You see an error here. It tells you uh, today could not find function ggplot2. It means we have not loaded the package called ggplot2. I think that should have been the first thing for me to do. So to load a package, you simply do library. So you have library, and then I'm going to have ggplot2, and then you can see it is there. So now that I've loaded it, it means I've brought the package into our environment. So I can now simply run it again, and you won't get anything. It's going to give you this plain ground here. It's going to give you something so plain like this. So it is plain because you only just say R and then, X and Y to interact, but you've not indicated how do you want them to interact. As is it a line graph? Is it a box plot whatsoever? So that is where ggplot becomes very, very easy. So when you run like this, you won't get anything. This is what you are going to get. And you would. So I'm going to go again. The second step is you add a layer using the geom. And that is where we now apply this. We have finished with the data. We finished with the mapping. Then we come to what? Geometrics. And that's where we use the geom. So if I come here, the third layer is the same plot I have here, but I have to add plus sign over here. And then the plus, what am I adding? I am adding a layer called geom underscore point. It means geom underscore point. For instance, sometimes when I'm typing, so I have here, so if I do plus, it means I am adding a layer. What layer am I adding? I want to now actually print what the figure. So I'm going to say geom underscore. Immediately you put underscore, you're going to have a lot of options. So whether it is a geom box plot you want to do, it's a geom blank, it is a geom color, all of them, you should know the kind of plot you want to do. So if it is geom point, I just start with my, and then you see that the geom point come in, and that is it. So if I don't specify anything inside the geom point, I can run it. Then you are going to see some kind of points that will be here. But with the geom point, I could have gone ahead to indicate the sizes of the points. And so that is going to be another layer. So you see that here, the same function I have here, but after I have finished, then I now add geom point, and then I enter into the point, this particular small bracket you see over here. So you enter there, it tells you that you can do some kind of specifications here because the geom point itself is a function. And so that is why it is followed by that small open and close bracket, which means there are some other argument it can take. So if I go inside, I can say size is equal to 5. If I run it there again, now these points are going to increase to a much more bigger, and then that is it. So you see that now they are looking bigger. We could have gone ahead there, inside there, and say that what color do we want for the I mean the point. Okay, I don't know if I needed to spell color completely. And then, so maybe let me put this color blue and see whether it's going to change again. So now the geom point, the colors even though the points are now at big like this, you see that we have, the colors are like blue. They are just like the way we wanted it. So the zoom point itself is the geometry, how you want the geometry to look like. But you can also specify the colors of the geometry. So here we are using zoom point. So it's like when we are plotting a graph and we do that. So the third layer, we are going to add a line to make sure that the line connects some of these dots. And see whether it may make sense. And so it is the same ggplot. Then you enter into the data. Then you select where the data is coming from, which is you have mapping, and then you have your so plus the geo point. We have finished with the geo point, and this is what we got. We want to add another layer. So we'll say plus. What are we adding? Geom line. Okay. So let's say this was where we ended. We ended around this particular place, but in our case, we put blue. So here it's just a matter of changing the color. So we are saying that we want to now add another layer. And that is the beauty of ggplot. You can add as many layers as possible. And then the layer we are going to add is this geom line. So if you run that, you see the line be connecting all the dot. Remember, we changed the color to red, and we changed the point size to 3 here. So that is why it is like this. And so the color of the geom line or the line is also blue. If we had changed it to red, then you will see everything there red. And then we're just going to run that again, and that will give us red. So this is the very basic way of plotting your graph. Now, step 4. Step 4 is a summary of what we have done. Now we have ggplot2 from line 2686 here, and then we are saying the first data entry is data. So when we come, we don't have to write this data is equal to this. It's a waste of time. Immediately RC ggplot2 as a function, it knows that the first entry is data. The second thing, don't bring the mapping again. You just have aesthetics, and then you don't have to indicate x is equal to this, y is equal. R knows that the first argument is for the x-axis, the next argument is for the y-axis, and that is all. So you just run that. Then you come and add your geom point, then your geom line, and then it will simply generate the same thing for you. Maybe this time around, I changed the font size again of the points to 2, and then the line is going to be yellow. And so the points will be black. The default points will be black. So if you run that line, yeah, so this is what you are going to get. But I actually added geom smooth. So the geom smooth, I'm going to take that out and run the line again. And so if I run this line here, I think there's an object O not found. I think maybe the yellow. Don't know if. So let me see where. And so I simply have this. So my point here, then I add my geom line, and the color is yellow. So run that again, and then yeah, that's just good to go. Maybe the points, if we had made the point, here, had given them a color, then we would have seen this here. So look at how it looks like. And so you can do a lot of specifications on all of them. So if I have, let's say, if you click on geom point here, so between the function and then the small bracket, when you click, if you allow your cursor to be blinking in the middle there, and to be blinking where I have it here, then you would always see this pop up to tell you how the argument will be taken. And so it means that geom point is a function, and when you enter the first argument will be mapping. It means you are going to still allow some variables to interact. So you can have identity, you can have position, you can have any dot remove, so that you can remove any if you have some or not available data. You can show legend, then in that order. But I'm coming to legend. And so that's how it is. Now, let's look at another part. So here, what we have done is we decided to add another layer called geom smooth. Anywhere you see geom smooth, it means that you are building like a model. So which means you are going to have two lines. When you are using Joom Smooth, you are building like what is it, a model. And when you have a model is actually predicting or is estimating some value. So you will have actual line and you will have the predicted line. And so if we run this line, you will notice that we're going to have, you see that we have two lines here. So one of the line is the actual. So we were expecting the data to go in this manner, in the blue one. But this actually, the red one with the points is how the data behaved. So the difference, the distance between the red and then the blue line is what we call deviations. And then that is what every model builder always want to smooth. So maybe here the model will predict this particular value, but this is the actual value. So the difference between the predicted and the actual is the residuals. So we have a way of nullifying that, and then we can easily do that. So if you want a model, this is what you do, and then the model you can select. You can select it if you want a linear model, if you want a what is it? You will see all the argument, the supposed argument that is supposed to be there. And so you have method is equal to LM, which means it's a linear model. So if you use Joom Smooth, you are printing a model, but you can specify. If you don't specify, it will automatically pick linear model. But you can specify because you also have geometric models, you have logistics models, and whatsoever. So generally, a generalized linear model is a matter of specifying by binomial as a family, and then you are good to go. So we also have second part. I'm going to look at another part. I've already mentioned this to you, and this is carbon dioxide concentration data uptake. So what we are going to do is here we are going to combine two things. I'm going to combine ggplot2 and then another package called Tidyverse. So if Tidyverse is not loaded, this is the package I'm talking about. Tidyverse allow us to be able to pipe out. To pipe out means to simply just what is it? Pick a portion of the data, and then you are able to work with it. So let's load the Tidyverse package, and then like this, I'm just going to put the Tidyverse inside there and run it, and so it is loaded now. So we've loaded it, but to mask some of the packages is normal. So when we come again, the carbon dioxide check for the variable names. So you see, we have plant, we have type, we have concentration, we have treatment, concentration, and then uptake. If you want more details on that, you just put a question mark to the data, and then you run it. Arrow will simply give you a description. But this is an inbuilt data, all right? So you need to pay attention to that. If it is your own data, and that the data doesn't have those descriptions inside arrow, you can't do that. Because if it's your own data, you should already know the variables you have. Here, because we're using inbuilt data, so but I will use my own data anyway. So we can check, we can just have some. So look at how the data look like. It's grouped by plant. We have data type, we have uptake, that's the treatment, we have concentration, and then we have plant. And so that is what we have here. And okay, we can go ahead and then maybe we should check the structure. If you check the structure, it will be able to tell us what kind of data it is, whether it is a data frame, and then we have our carbon dioxide, CO2, CO2 here. And then, so let's check and see what kind of data it is. It's actually not a data frame, as you can see. It's not a data frame, but we will try. We'll try our possible best to see how we can. So here we have the data called CO2, that's carbon dioxide concentration uptake. We've already seen how it looks like. It's here. You can see it here. Format. It is an object of class C. Something is a group data. Something NFN group data. Yeah, you can look at the definition here containing the following. It's kind of like data that has been grouped, and we can look at the groupings. So you simply have the variable here, and we are now using the tidyverse to do this. So when you say percentage greater than percentage, it is called pipe. Pipe means you pick portion. So we are picking a portion, some of the variables we have here. So let me clear this part. Come again, come and print the header, and then so these are the variables. So when we use the pipe operator, we are selecting part of the variables, but maybe we're not looking for all of them. So what are we selecting? We are selecting something and putting it into ggplot function as, and so immediately you use aesthetics. And when you are using the pipe operator, you don't have to indicate the data again. R already knows that this is where the data is seated. So the first part is the data frame. So you don't have to indicate the data here. So you have ggplot, then you go all the way and just start with aesthetics. That's where you map the X and Y. So the X will take concentration, Y will take uptake, and then the color will be based on treatment. Here, if I decide to run this line alone, you won't see anything, just like we have. So we decided to add a layer. So plus. So the plus is geom point. We are going to use a geom point, and we say the size is 3. Alpha is the alpha tells you how transparent or how deep you want the image to look like. And so that is it. So I can again run the data all the way up to this place without the plus. And then you see that this time around, I have it. Look at how it looks like. We pull that out. So we decided to look at concentration and then uptake. And then and then we decided to say that the color should be based on treatment. So the treatment, we have non-chilled and then chilled. So wherever you see red, it means non-chilled treatment. Wherever you see blue, light blue, that is a chilled treatment. This is one of the ways through which we could have the color here. If we had chosen a different color, then it would be a uniform color. For instance, if I come here and then I said the color should, you put it inside, let's say, what is it, green. So it means all the points here will be green. So let me run it. If I run it again up to this place, you will notice that all of them, you see. But ggplot is very funny. When you choose a specific color for it, unless you are using color plate, it will select its own color. But to select it, it will tell you that it means you want a uniform color. So it selected this particular color, the default color for it. And so all of them will be the same color. But you can say that, no, I want the color to be based on this particular variable treatment. So if the treatment is chilled, then it will give it a different color. So it will select the color automatically, and it makes. So we ran up to this point. So let me run it again up to this point here. And so if I run that again, so you notice that, yeah, it's going to have already explained this. So we can add another layer. This time around, we are adding what? Geom smooth. And we are saying that we want a linear model. And then what is it? And we are ignoring some kind of errors. Maybe let's say the square errors or the standard errors, we are ignoring them. So we say it's false. We set it to false. And then that is it. So let's go all the way, run the line all the way up to this place. And so we are not adding facet wrap up to this point, and see how the graph will look like. And so you see, because we have added geom smooth and we say we want a linear model. And remember, we've separated the plot by different treatment. And so we'll have the smooth for the red, and then for the chilled. So the non-chilled is the red, the chilled is the blue. So we're going to have two lines. And that's why, so we're using two linear models here. And you can see how the models are performing. Now, if I add facet wrap, what I'm simply saying is that, but let me zoom this, and then you can have a feel of how it looks like. So this is how it is. So you see how it looks like. So because we've added geom smooth and we chose linear model, this is how the data is going to pan. So it tells us that when we have concentration and uptake, this is how concentration and uptake is interacting in terms of non-chill treatment, and then in terms of chill treatment. So two things. So, but let's add facet wrap. Facet wrap will divide and then the facet wrap, we are going to say that it's going to be based on type. It's going to be based on type. So the facet wrap simply allows us to divide the plot into several segments based on a particular given variable. So we already know that the data contains something called type. So that's the type of plant. It can be a cubic, it can be a Mississippi. And so I'm going to run it again all the way up to this point. And so when we add this layer called facet wrap, which is equal, and then we say tilde equal type, we are saying that separate the entire graph based on plant type. And then, so it will simply, and then you see this time around, it has separated it based on the, so you see that here we can now analyze the data very easy. We have our concentration down, we have our uptake over there, and then and then this is the plant type, this is the Quebec, and then we have Mississippi. So we can look at how the uptake, the concentration and uptake, the concentration and uptake is working. We can look at our two models there based on whether chilled or non-chilled treatment, and then we can analyze this based on the plant type in terms of Quebec. So we can do all the concentration for Quebec, we can do that for that of Mississippi, and then we can now compare the two of them. How so? By this alone, you are good to go. Let's check what next we can do. So we can now add labels and other things. So the last layer is to add a label. And then ggplot, we use title to actually mean the title. And so here, if I run it all the way up to this place, so this time around, what am I doing? I am simply saying that I'm adding labels to it. So you can see now we have a CO2 concentration as the label. As we just put it, the label is here. And that's where you can, if you change this place, you are good to go. Now the team allows us to choose this background. This background that you are seeing is because of the team. Uh, uh, this is the default background, but we can actually have a different. We can add the team, and then we see what is going to happen. For instance, the team will allow us to. I'll choose this one, and if the team is, yeah, so you see that now the background is a little different from the one we had earlier. So you can see we don't have the gray background again because we choose the team BW. Team underscore BW, and that's what happens. So it gives us a different background. We can actually choose different team if we choose to. And then at this point, maybe you are good to go. Then what is it? You can just work with your with your plot. Let me say that this treatment, the treatment we have here, we could actually choose different colors. We could actually choose different colors for us to be able to specify that maybe some people may not like this color. You can choose a different color, not allowing R to choose its default colors. You can choose different colors, and that is it. So here, that's how it works. And then, so immediately you see this, you always start, if you're using the pipe operator under the tidyverse, then you are using the data frame first, and then you are piping out. It means you are picking some part of the variables out, and you don't pipe out rows. I haven't seen that before. You pipe out columns, and the columns are called variables. The rows are simply observations or entries. So you pipe out the variable. So you have the data. So when you come to ggplot2 or ggplot function, you don't have to indicate the data again. So I have concentration, uptake again, and then blah, blah, or everything that is here. Then we can run that again and then see how it is going to. So we have, yeah. So here, the team, because we have changed the team, this one is now team classic. That is why it gives us this outlay. So this is team classic, you see? And then the data is here in that order. So you can actually deal with, analyze, or visualize your data in a manner that you want. Now, I have this data that is seated. It's called cookies. I don't know if the data, what is it, is still there. Cookies. Okay, maybe I need to import the data. It's called cookies. I don't know what I have imported. I have a function, but you should know how to import the data. Cookies. Okay. So what I'm going to do, I'm simply just going to say, I'm going to say the function is cookies, and like this, and I'm going to say, I think it's a CSV, it's an Excel file. So read underscore Excel, and then you come here and say file, what is dot choose, then file dot choose is here, so that when you run it, it allows you to be able to go to your local computer and select the file where the file is seated. So if I run that, it's going to tell me that I don't have Excel, could not find a function called Excel. So I need to come to my packages and update the Excel package. If not, it won't allow me to be able to go. So I'm going to go, I'm waiting for it to load. So I have Excel. Yeah, it's here. So if I activate this, and I go back to run that line again, come back to run this line 2742. So let's see that this time around it works just well, and you can see it is blinking here. I'm going to go to my, I don't know whether it's on my data, it's on my desktop. I have cookies. If it's not on my desktop, I will check on a different form. So I think there's one here. I don't know whether it is this eateries. And then, yeah. So let me see if it worked. Yep, I think it did. So the data is here. Let me pull it up a little bit. So you can see how there are different foods. We have town food, a unit sold, revenue, cost, profit, date, and then in that order. So we have something called what is it? Nadio number two. It's a huge data, and then you can see we have 700 observations and then 7 variables. So that's what we are going to work with. And there are some few things I need to do here. So I could have just used this to look at the structure. So it's actually a data frame. So you have the structure, which is a data frame seated here. So let's see how we can visualize this. I think here, there was something that I did here. So I'm going to jump that part. And so, because if I have to rewrite the whole course all over again, it's always time consuming, and that's my problem. Where was I? Where was I? Okay, so I think I've already explained this part. No, I haven't gotten to this, please. I have not. Yeah, this is where I was. So I was saying that, so here I'm trying to, let me even try and see if I run it, it will work. Error, could not add something here. So here, let's say I have cookies here and I'm piping out into, so I'm going to say town, and then I'm saying profit, and I say the color should be based on the food and the size is equal to revenue. And then I finish with that. Then I add in a layer called, I want it to be, the layer is going to be box plot, and I want the position to be Dodge, and the outlier dot shape is equal to 19, and facet wrap to be based on year. You see? And so I just run it, and then I'm noticing that there's can't find what is it? I don't know which line did I run. I ran this line, or where was I? Okay, I'm trying to figure out what the issue is. So I have my data here. I'm piping out town. For instance, okay, let me put here. What is it? Names. Then the data is loaded, and so you have town, food, unit sold, revenue, cost, profit, and then date. So here, let's look at something. So I'm piping out town, profit. Maybe there's something I've specified somewhere that, and I'm saying, okay, let me remove this section and see. I try running it again and see. Can't add CO2 to ggplot object. What is it? I'm unable to get the what this error is saying. I don't think I'm adding anything here. Well, in any case, we have an idea. So let me try my possible best and see if I can fix this. So let me try again. I have, okay, well, let me come down here. So I have the cookies, and then I am piping out into GG plots, plot comes, and I'm saying that my this I want town to be my, and then I have my profit. The profit should come, and then I'm saying my color. Okay, my color should be based on the food. Color should be based on the food. And I think I'm going to leave it here. Run this and see what is going to happen. I think I've run a line, and that line is still not. I've run a line that is making it difficult for me to be able to run this line again. Okay, now let me come and run this line and see what will happen. Yeah, so this one works just well. But I don't know why my own data is not. So these are for the sake of time. So we have treatment uptake, but in this case, we are using a box plot together with a zoom point. And then we are saying that the color should be based on plant, and then the size should be based on concentration. And that's all. So when we run that, look at how it works here. So we pipe out from the ggplot2, where we have treatment uptake, and we add zoom box plot. If you want to know the other argument you can add to box plot, you can actually click here. It's going to give you, okay, is, and then you have zoom point. That's the zoom point you are seeing over there. Then you go to your facet wrap, and then you have your team, you have your labels, and then you're good to go. That's why we run, and then we have this. Where I have a problem is when I'm running my own data with the same syntax, but I'm not getting the so maybe I will ignore that because I'm doing this on live session. It's going to waste a lot of time. But now we should have clear, what is it, some kind of understanding of how we are able to plot. So the first part is there. Then you now begin to add your layers in that order. Now the fourth part was here. We're going to, I mean, what were we here is only box plot, and then where the size is based on the, and so we are using this particular data, which is called the MPG. It's actually about cars. And so let's try and see how. And so we are saying that the x-axis will take the piston displacement, and then y will take CTY, and that's all. If you run it up to this point, you should have nothing. So when you add zoom point, and the size of the point should be equal to the car type or the transmission type, whether automatic or manual. And so if we run it all the way up to this place, we run the line all the way up to this place, we should be able to, yeah, so you look at how it looks like. But at this point, the graph may not be able to give you vividly what you want, but you can see that piston displacement and then the CTY, you can see that it's actually negatively sloping or is downward sloping. Okay, so maybe when we add the zoom smooth, the model, we can see the pattern and we facet wrap it based on years. And then And then let's see. Let me try to run the entire and then see what will happen. Yeah, even though warning, the size for a discrete variable is not advisable. Yeah, I do know that. I didn't have an option, so here we come and look, can compare the two cars and how they are doing. So you have 1999 and 2008. And we're looking at piston displacement. These are the cars types, and then these are the what is it? The piston displacement here, and we have the CTY. Then we can look at the transmission is based on the what is it? The sizes of the plots or the points is based on the transmission type. So we can look at whether it is a four-wheel, it is automatic, it is manual, and then in that order. So based on the type. And the color is based on whether it is a four-wheel, it is forward, it is, I don't know what the arm is. We can go and then define it. So when you see, and the color, if you see the color like looking like this, so it means actually F here, maybe that's the F drive. So then you look at it, then you look at the size. So if the size corresponds to something like this, so you know that it is auto S5. And then you'll be able to look at the displacement here as against the CTY, and then in 2008. So it makes summarize your data a little bit closer. Yeah, so I mean, these are some of the ways through which we can. So here I was having read.table is actually a table with a header, and then that is true. We put it inside here. It's just like you just create a table, and we just do a bar plot, and we are going to convert it into a matrix and then make it as a bar plot. So when we do that, we are likely going to have a stack bar plot, and then look at how it looks like. Yeah, and so this is a stack bar plot, but I think I have a better stack bar plot somewhere, which is seated. So more of ggplot2, you have just creating some kind of data here. I have a species, and then I'm using the repeat function. I'm going to repeat this 3 times, repeat this 3, repeat this banana. And then I also come conditions. I'm going to say normal, stress, and then nitrogen. So I'm going to repeat this whole vector. I'm going to repeat it 4 times. So 3 times 4 will give us 12. So 3, 3, 3 will give me 9. Are you sure I am on the right path? Well, let me try and see. Then I also have this, another 12 here. And then which one again? Okay, yeah. So here, maybe, I think. Yeah, there was another one. Yeah, there's another one here. So that will give us 12, 12, 12. So when we finished, run the whole thing, change it into a data frame, then we are good to go. So now if I print the data frame here, you should be able to see how we have created the data. We have the species, we've repeated the species 3 times, the conditions, then we have the value. So we can go ahead and then generate a stack bar plot with this, or a group bar plot. And so we have ggplot, and so we say data, and then when we come to, remember, we've packed the data frame into something called data, and that's why we are using, it's not the function data, or it's not the argument data. So we have ggplot here, and then we have the first argument is the data, that's the data frame. So we have our aesthetics. So our aesthetics is going to be the x-axis, which is field, which is going to be equal to conditions, and y is equal to values. And then our x is equal to species, plus this one, we are going to do a group bar chart, which is a little bit different from what we have been doing. And so let me run that, and then you see how. So if I run up to this place as usual, you won't get anything. This is what you are going to get. You will not get anything at the moment. But immediately we add geom_bar, and position is dodge. Statistics is identity. We are simply trying to build a group bar chart. So now I'll run the entire, and then you look at how it's going to look like. So this is the group bar chart. So when we come to banana, we can come here and look at nitrogen, normal, stress. So we have banana, when it comes to banana, we can look at the nitrogen, and then we can look at the normal, and then we can look at the stress. So here, this kind of what a plot is very useful because you are actually combining more than one variable and you are measuring them at the same time on one item. So we are looking at banana, we're looking at nitrogen, we are looking at a normal, and we are looking at stress. We can come here for see we have in the same way. We can have that, we can have that, and then that is it. It's just what is it, a way of like. So we could actually also do that for a stack bar plot, but the difference will be that okay. Now let me run this the same data that we have just is the same thing here. But here we are going to use the same ggplot to produce a stack bar plot, which is very, very useful. So the stack bar plot, you're going to start first with a field. Instead of taking the x-axis, that's where you have your field, and the field will be based on what you have created here. It will be based on the conditions. So if the conditions are 4, 5, then you see that the field will be based on, and the conditions are here. So the y value, the y will be based on the value you have created around here. And then the x will be based on species. So actually, we could have started with x. Sometimes data scientists will also try to hide some kind of the secret. This thing is what it is, nothing. And then we also have the species around here. And then when we run it, we say jump by position, we say stack. The other one we say position was what? Dodge. That's why we had it group bar chart. If you want it to be stack bar plot, you choose the position to be what? Stack. And then I'm going to run that. And so that's going to give me a stack bar plot. A stack bar plot. I like this one. Now, before I go, let me redo this so that people will understand. So we've already created the data, which is seated there. It's a data frame. So but I'm going to do, so I want to say ggplot. So I have ggplot, and so the data is called that. So that's data to species, and then my y is equal to value, and then my field is equal to the field is going to, it means how to fill the colors. It should be based on the conditions, and then it should be based on condition, and that's all. So now if I leave it around this particular place, if I run it here, I'm going to get nothing. Yeah, you're going to see plain. So because I'm using ggplot, I can add a layer. So I'll say plus. So what am I adding? Then let me enter a little bit. So I'm adding geom underscore bar. Geom underscore bar. But when you're using geom bar, you have the first argument you can pick is position, because you can actually pick the rest of the, but you can pick position. So here we are interested in position. And so position will come is equal to what kind of, so we want it as what? Stack. So I will say I want it as a what? Stack bar plot. If I leave it here without adding anything, so what I'm going to do is I simply run from here up to this place. So you're going to see stacks. Okay, I think there's something that is missing. Okay, so all right. And then there's the I should have finished with this. I didn't finish with this. So that will give me identity. Yeah, right. So let me run this up to this point and see what will happen. Yep. So that's what I was, because I didn't finish the argument, confused my program. So here you see that we now have our stack bar plot, and then it's practically this plot, and then the previous one is the same. This plot And then the one we plotted here, the internet is fooling. Yeah. So this one and the group what bar plot is practically the same. The only changes is the position. If you change the position to dodge, it will give you group bar plot. If you change it to stack, it will give you a stack bar plot. And the interpretation is practically the same. These are also stack bar plot, let's say, but mostly if you want to produce a stack bar plot without ggplot, using the ggplot package, you can do that basically like what I'm going to do here. Just going to create a matrix here. So I've created a matrix of rains. Then I have to create my colors. The colors should be the same as the number of rows, right? The MAMS should be based on the number of columns. So we're going to look at rainfall pattern according to MAMS. The colors are based on number of rows. If the rows are 3, the colors must be 3. If the columns are 5, then what is it? Here, it should be 5. And then we also have the regions, which is here. So let's finish the whole thing and then look at how it works. Okay, so if I run the whole thing here, so it's okay. So my I'll just simply say bar plot and say rains. Bar plot, the first entry is rain, what the data. So here I have rains. But how does R able to produce a stack bar plot for you? You have not used stack anywhere. You just use bar plot. It is because the data is in matrix format. If the data is in matrix format, then you are definitely going to produce a stack bar plot if you use bar plot. If you use bar plot with data frame, you are going to get the ordinary bar plot. If you use bar plot function with matrix data, it's going to produce a stack bar plot for you. So here we come here, and then we have our first entry as rains. Then main will give you the title. So it's a rainfall pattern. So maybe let's say I have rainfall pattern. So you have name.argument. That the name.argument is what gives you the label, the what each of the stack bar plot, what will be the name. Each of the name of the stack. That's where, so you want each of the stack to be named according to MAMS, and we have already created the MAMS which are seated here. So names.argument is equal to what? MAMS. X label, or that one you know. So, and or the x-axis, what do you want it to be? Y-axis, and then the colors. So color, we have to specify. Color should be equal to what? According to the colors. You have already created your colors, which is here. So you say color is equal to this. If you don't specify this, arrow may give you an automatic color. So when you do this, now you see that you have printed your stack bar plot, which is very simple. So now I can compare the rainfall pattern. This is January, March, April, but this one, it looks a bit ambiguous. What is the yellow standing for? What is the blue? What about the green? Okay, we'll move a little further and we'll see what that means. So what we can do is we add a legend. So the legend will be able to describe to us what they all mean. So we say legend is a function, and we say, where do you want the legend to be? Top left. And we are saying that the regions, the legend should be based on what? Regions. That's where we created the regions. And then this one is just the size, the size of the legend. And then the legend should be filled with what color? The colors you have already used here. And that is it. So if I run this, it will simply add it. So you can see the legend is now seated at the top left. So you can see the legend is now seated here, but it's extremely small here. So we have northern region yellow, blue is western, and then green is eastern region. So here it's not easy for us to compare the rainfall pattern in January in that of northern region, western region, and eastern region. We can say in general, there are more rains in March. in the three regions, followed by more rains in July in the three regions. But when we come, we realize that in Western region, we have more rains in May as compared to the rest. And then in July, Western region, the rains reduce completely as compared to the rest. And then in that stack bar plot interpretation is very interesting. And so that's how it is. Now we can also produce, we can generate as many. So this another one was trying here. Here, I don't have to explain again. Now you know what that means. If I run this again, so this another stack bar plot. And then that is it. Remember these colors, you create the colors according to the number of rows. Because you are using bar plot to create a stack bar plot, remember the data must be in matrix. If you are using a data frame to create stack bar plot, then you are using ggplot and you are using the function geom_bar and you specify position as stack. But if you are not using ggplot and you are using the ordinary inbuilt bar plot, then you want to create, let's say, what a stack bar plot, the data have to be in matrix. If it was already in data frame, convert it into matrix, and that is what you can do. If you convert it into matrix, the number of rows should be the same as the number of colors you want here. Then the labels that you have for each bar should be equal to the number of columns. Each bar here represents a column. Each what is it? Color here represents a row. As you can see, down here is the row for red, followed by the row for blue and the row for yellow. You see? So that's how it works. Get this. And then you can always add your legend. If I add my legend to it. So you see that now I can add a legend anywhere. This top left, you can have top, bottom left, center, what is it? You have center up and then the center, what is it? You also have right, top right, and then bottom right, then in that order. So this was a little assignment. This is a little assignment I want you to, and this will be the last one. So 5 newly developed varieties, variety 1, 5, 1, 2, up to 5 of maize were tried in 5 different locations in Ghana. If 30 bags were obtained in all, with varying number of bags or bags each from each variety, from each location, explore the data and provide expert advice. So we just decided to create the data here, which is 30 bags, and we are saying that, okay, this one is just 10 bags below. Then we say our number of rows is going to be 5, number of columns to be 6, and by row is this one is just to create the matrix. So the colors must be the same thing as the number of rows. So you can see the colors here are the rows. Then remember your name.argument is going to be the number of columns. So the number of columns here will be according to the locations. So the locations we have Ejura, Yendi, Bongo, Sophie, and then Najo number 2, Konongo. So we have the varieties here. The varieties will now be based. That is what is going to specify the what is it? The specific, or that's going to define the legend for us. And that is it. So, and remember that the variety or the legend must always be equal to the number of locations or the number of things where you are doing the trial, where the treatment is being meted. So we are doing it in Nigeria and Co. So we are looking at variety 1 in Nigeria, variety 2 in Nigeria, variety 3 in Nigeria. After that, we move to END the same way, and then in that order. So that's what we should put at the back of our mind. So if we run the entire data like this, then we can run this, and then we add small legend to it, and then we bring this out. So you see how it looks like. So we have our title, and so we can say that the colors are now, look at where the legend is. So we have, but I think that the legend has covered the, what is it, the down part. and, and it's too big. Maybe I should reduce the size of the legend. So the legend, we could have reduced it to, let's say, zero point 0.3. Let's say in this place, I'm going to change it to top left, run it all over again, run the entire code all over again. Yeah, so here is a little, it's not covering. So here we can look at Ejura then and how all the varieties are faring in Ejura. We come to Yendi, how all the varieties are faring there, then in that order. And so here it makes the interpretation very easy. We can say that in all, there's more performance in Ejura, followed by Sophie, and then followed by Najo number 2. Little performance in Yendi. But that doesn't mean that all the variety didn't do well in Yendi. We can see the blue variety did better in Yendi than Bongo. And of course, even though Ejura performed well, when it comes to the red variety 2, it did not do well in Ejura as compared to how it did in Sophie also. And that's how we are able to interpret it. So this is how we visualize data. I am unable to do tree, how to be able to visualize tree, like phylogenetic tree. I'll do that in a separate video. Watch out, and then I'll leave it here. Okay, thanks very much. If you enjoy the videos, please, it's always a pleasure trying to bring data science to a very simple way of understanding. Thanks. My name is Big Bright. If you love what I do, share the videos. Allow your colleagues to also learn from it. And then why don't you give me a subscription, and then we're good to go. Okay, so I'll leave it here. Watch out for the next video I'm going to do will be on how to do phylogenetic tree, how to do binning, and then principal component analysis, visualization, how to visualize them and interpret them as well. Okay, bye-bye.